Okay, so we can start with implicit. Acha. Okay, before I start with implicit functions, I just need to explain you what implicit functions is. So, just very briefly, implicit functions are functions in which x and y have equal status, to be precise. Implicit functions are functions in which the variables have equal status. Now, when I say equal status, I mean there is no dependency or independency involved. Like for instance, when you have an equation of velocity in terms of time, let's say v is equal to 2t. Velocity is equal to 2 times t, let's say. So there is a dependency involved. Time is an independent factor and velocity is dependent on time. So that is the reason why velocity is always plotted on the y-axis and time is always plotted on the x-axis. And I think even in O levels you must have studied this, and if you remember, someone must have told you that the independent variable comes on the horizontal axis and the dependent variable comes on the vertical axis, y-axis. Now this is a convention we follow. So that's why you have always seen time on the x-axis. And you've always seen velocity, acceleration or any other quantity always on the y-axis. So the convention is that if you have variables in which there is a clear-cut dependency involved, like in a displacement time equation or a velocity time equation. So you have the quantity which is the dependent variable coming on the y-axis and the independent variable coming on the x-axis. But there are a lot of equations in which the variables have equal status. There is absolutely no dependency or independency involved. And we've done those kind of equations. We've done it in the chapter known as quadrant geometry. In quadrant geometry, x and y have equal status because they're not representing any particular quantity in reality. So, okay, this is again something that you have not consciously observed, but now you need to be conscious about it because now we're creating a distinction between implicit and implicit functions. If you remember in your O levels, you must have drawn many graphs in just simple O level math. I'm not talking about high math, I'm talking about O level math. And you must have drawn graphs relating cost versus quantity sold, quantity produced, revenue versus quantity sold, velocity versus time, acceleration versus time, displacement versus time, and so on. So, and you were free, if you remember, you were free to use any scale on x-axis and y-axis. Sometimes you used a scale like 2 centimeters representing 1 unit on the x-axis, but on the y-axis you used 1 centimeter representing 1 unit. So you were free to use any scale as long as it was covering most of the graph paper and you were getting a convenient graph to make. So you used to alter the scale accordingly. But if you, I don't know if you realize, in coordinate geometry, whenever we've sketched a graph or we've plotted a graph, we've always taken the units same on both axes. When you're making graphs for coordinate geometry, curves or straight lines or circles, you do not take unequal units on the axes. You take the same unit on both axes. The reason is very simple. Because both x and y have equal status, that is why you cannot take different units on different axes. You take the same unit. If you represent it on the x-axis, if 1 centimeter is representing 1 unit, you have to take 1 centimeter representing 1 unit on the y-axis as well. Otherwise, perpendicular lines will not appear perpendicular in coordinate geometry graphs, and circles will appear oval. They will not appear circle. Are we okay till here? If you remember, a straight line equation was given in two ways. Either you could write a straight line equation, let's say y is equal to 2x plus 3. Either you could write this equation like this, which is the slope-intercept form. Or you could also write it as 2x minus y plus 3 equals 0. Now, this is what we call the general form. Now, in a lot of occasions, there is absolutely no difference between them, but there's just a difference of perspective. This is what we call an explicit equation because y has been explicitly expressed in terms of x, whereas this is a classic example of an implicit equation. Now, your argument would be that any equation can be made implicit or explicit. Yes, any equation can be made implicit or explicit, but it depends what is that equation representing. If your y is velocity and your x is time, I would never write the equation like this. I would always write the equation y is equal to 2t plus 3, b is equal to 2t plus 3. You would never see in any physics book or anywhere the equation as 2t minus b minus 3 equal to 0. Never. You would never see it like this. Because there is a clear-cut dependency and independency involved between velocity and time. Velocity and time do not have equal status, so they have to be expressed explicitly. You have to say v is a function of t. So you can say v is a function of time. जब आप कहते हो y is a function of x, when you say this, y is a function of x, what are you trying to say? You're trying to say that the values of y are dependent on what values of x you receive into the function. What values of x are given as an input into the function, that's how your y will respond to. There's going to be an equation through which you get the answer, but x being plugged as an input and y being received as an output. So y is dependent on x. So y and x don't have equal status. There's a clear-cut dependency and dependency involved here. So you explicitly say y is a function of x. Y is expressed as a function of x. Velocity is expressed as a function of time. Even displacement, let's say, S displacement is a function of time. If you will plot displacement versus time, displacement will always come on the y-axis. You don't have equal status. So you can't flip, maybe I'll put the displacement on the x-axis and put the time on the y-axis. No, it doesn't work that way. In coordinate geometry, by the way, you can always flip, depending on how your equation is given. It's just a convention that we follow, that we have y and x like this, but because y and x have equal status in coordinate geometry, we take the same scale. 1, 2, 3, 1, 2, 3. The scale has to be the same. Whereas when you're talking about displacement in time, you can have maybe time like this, and you can have a scale of displacement like this, unequal scale. You are very much okay with that. And you have made various graphs and levels with different scales. And if at that time, obviously, you were not conscious of the fact why you're doing that, but now you know why you were doing that. It's because the quantities that you were expressing on y and x had an intrinsic independency involved. Are we good? I'll just give you another example of coordinate geometry where we never express the equation explicitly. And the classic example would be of the equation of a circle. Let's say I take a very simple circle centered at the origin, having a radius of 2 units. Very simple circle centered at the origin. Do you know what is the equation of the circle? Yes. This equation of the circle is x squared plus y squared equals 4. This is the equation of the circle. Never will you ever see in any book the equation written like this. कभी भी नहीं देखोगे आप. Because this is an explicit way of writing. We would never write this equation explicitly. You would never see it this way. Because x and y have equal status, circle is a classic example of x and y having equal status. And this is not the way you would represent. Although likhne mein to you can write it that way, but it's just that you would not want to express it. The convention doesn't allow you to express it this way.
Change the shape of the.
No, you will get the same answer. The plus root 4 minus x square will give you this half, and the minus 1 will give you this half. You will get your graph with this equation as well, but you will never see any book expressing the equation like that, because it would be unconventional to do so. Why? Because x and y have equal status, so there is no need of expressing y expressing x. Unless you know that y and x are representing some quantity. And if they are representing some quantity, then y and x need to have equal status, because then this will not appear as a circle. And for it to appear as a circle, we need to have the same scale. If I scale change kar dunga, it will become an oval. For the same readings, it will become an oval. It will not look like a circle. Are we good? So that's the distinction between explicit and implicit functions. Are you all good till here? Okay, this was the theoretical aspect of it. So I thought that it's necessary that you should know the difference, because solving the equation, that's something very simple. You can learn that. If someone asks you what is an implicit function, you should know what an implicit function is. Okay, now before I move on to the differentiation part of this, there's a few things I need to mention. But we'll do the differentiation part later. I just want to mention a few things. One is that every one of you, and I'm pretty sure every one of you, is habitual of, but we all do that. I mean, no exception. But no, not C, not but there is what I need to make you conscious of something right now before we move on, because unless you're not conscious of that, you cannot do implicit differentiation. There is an intermediate step that we all take it for granted and we don't write it. It is exactly the kind of thing that we take for granted in math when we're doing something like this. 2x is equal to half 1, so we say therefore x equals half. Now, the 2 doesn't jump on the other end and go down. It's basically you're dividing by 2 on both sides. Now, this is an operation we all take for granted. But we should know that this is exactly what is happening. 2 दूसरी side में जाता नहीं है नीचे. You're dividing by 2 on both sides. And the same case over here, this doesn't happen, that x plus 2 is equal to 1. So you get x equals minus 1. के 2 उधर उठ के जाता है, ये जो हम करते हैं ना कि 1 minus 2. That doesn't mean it just hops on the other end and becomes minus. It's what actually is happening is you subtracting 2 on both sides. This is the operation, because by law you cannot have an operation in mathematics done on one side of the equation and leave the other side lying around. So that same operation needs to be done on both sides. That's by law. So what we need to understand over here is that differentiation is also an operation. And the operator is this, d by dx. This is the operator. It's called a differential operator. So differentiation is an operation that we do on both sides of the equation. This is what we need to, this concept needs to sink in now. And the intermediate step that we are missing out is basically what we are doing is we are taking d by dx on both sides. This turns into dy by dx and this turns into 2x. It's an operation you do on both sides of the equation. So d by dx of y is written as dy by dx. dy by dx khud kuch nahi hai. There's nothing like, because I don't know how you've been taught, but I think we discussed this last year as well. When we were doing differentiation, I did mention this, that it doesn't suddenly pop out like that. Dy by dx in itself is nothing. It's differentiation of y with respect to x. And it's the result of an operation that you do on both sides of the equation that results in dy by dx. So it's like, if you remember, whenever there was no y, I used to always write like this and write the answer. I used to always write like this, if you remember, because I want you to understand the fact that अगर y कहीं पे given नहीं है तो आप खुद ही एकदम से y नहीं ला सकते in the equation. कि अगर if the question is saying differentiate x square with respect to x, so that doesn't mean dy by dx equal to 2x. So there is no y anywhere in the equation. So you can't just bring the y suddenly like that. You can't just introduce a variable suddenly like that. So writing में तो it makes it very easy. हर चीज को dy by dx, dy by dx, dy by dx, but that's wrong practice. That wrong practice leads to a wrong concept later. And every year it takes me, just like I'm doing it right now, every year it takes me 20-25 minutes to erase that concept and bring the correct one in. Because that ease with which, just so that we could have an easy way out, we do dy by dx, dy by dx, dy by dx, but okay, it seems easier at that time, but that's wrong practice. You can use the dy by dx if there is a y given. If I say y is equal to x square, okay, then fine, dy by dx is equal to 2x. But if the question is saying differentiate x square with respect to x, how can I just write dy by dx equal to 2x? Y can't say आगे बीच में. You would write d by dx of x square, because this is an indication that the differential operator is being applied on x square and the result is 2x. That's what we need to understand right now. d by dx of x square. Now, if there is a mismatch of variables, see, there is no mismatch of variables here. So you're differentiating an x square function with respect to it, therefore the result is 2x. So if I say, what is d by dx of p? Now I don't know what p is. P might be a function of x, p is a function, I don't know what p is. So I would just write it as dp by dx, this is the result. Now if you tell me, oh, so p is x cubed, then I would say, okay, so if p is x cubed, then the result is 3x squared. The result of what? The result of differentiating p. You are actually differentiating p with respect to x. अब अगर मैं आपको बोलूँ कि if p is equal to x cubed, then okay, fine. dp by dx is 3x squared. But the result 3x squared is the differential of p with respect to x. And that's a different story, that p is a function of x. So therefore you got the result as 3x squared. But that is dp by dx. Is everyone okay till here? This is very important. So if the same question I ask you, then I'll give you y is equal to x, and I say differentiate with respect to x. So you'll very easily tell me dy by dx equals to 1. But for the same equation, if I say differentiate with respect to y, so then basically what should happen is this: you would be doing d by dy of y, d by dy of x. If I ask you, no, take this equation and differentiate with respect to y, give me the derivative with respect to y. This is what I'm asking them. So d by dy of y would be a 1, because the variable is the same. The differential of y with respect to y is a 1. Just like the differential of x with respect to x is a 1, because this is basically dx by dx, which is a 1. This is basically dy by dy. The ratio of two same differentials is obviously, the ratio is going to be a 1. So this is a 1, and therefore on the left side, on the right side, you get dx by dy. So basically your question answer is dx by dy is equal to 1, because you differentiate with respect to y on both sides. And same thing for this. If I take y is equal to x squared, and if I say what is the differential with respect to x on both sides, so you would say, okay, fine, so dy by dx of this, dy by dx of this, so that's dy by dx equals 2x. But if I say no, take y equals x squared, but differentiate with respect to y on both sides, so you will go d by dy of this and d by dy of this. Now this is where the implicit differentiation comes in. So this will become a 1, no worries about that. This you need to now understand. What would be the differential of x squared with respect to y? Now see, this is where the chain rule comes in. If you, the answer to this, by the way, would be, it would be 2x dx by dy. This would be the answer.
We write dx by dy?
Yes, you will write dx by dy.
It has a value?
It has a value. And then if I ask you what is dx by dy, you would say 1 upon 2x. And then if I ask you what is dy by dx, in the reciprocal you would say it is equal to 2x. So it has a value.
What's the value of dx by dy?
dx by dy, the value is 1 upon 2x. And it's dependent on x, whatever the value of x is at that moment.
So to complete the entire thing, we take 2x.
Yes. The idea is if there is a curve and there is a rate of change of y with respect to x, if y is changing with respect to x, so can't I find out the rate of change of x with respect to y?
Yes.
And what would that be? That would be dx by dy. That means I will have to differentiate the function with respect to y. The differentiating with respect to y at the rate at which the function is changing with respect to y. कि अगर मैं y में change लेके आता हूँ, how much change would it bring about in x में? Because initially when I'm saying dy by dx, I'm trying to find out what change would y would be having if I were to make a change in x. So the perspective is different.
So like you said that.
अच्छा, ये कैसे आता है ये मैं आपको बाद में समझाऊंगा. अभी मैं आपको सिर्फ theoretical aspect दे रहा हूँ.
Like you said, y is a function of x.
Yes.
तो समझ आ गया जैसे x square है. If you are doing dy by dx, तो cos 2x आता है. But जब हम d upon dy कर रहे हैं, x square में कहीं y तो है ही नहीं.
Then x square का y है ना? Y is equal to x square. X and y are related to a function. There is a relationship y is equal to x square, and that relationship will also give you the derivative of x with respect to y. That will give you the derivative of x with respect to y.
So I will get the 2x d upon.
अच्छा, ये कैसे आता है? This I'll explain you later. कि ये कैसे आता है? For that I'll have to discuss the chain rule. I'm just giving you a theoretical aspect of. Then both variables could be used as a differential operator. This is what I'm trying to say. You can differentiate with respect to both variables of the same equation. Are we good? Yes. So we just need to